there. So. Okay, we're doing example number 5 in carpentry. A carpenter is making tables. The tables have rectangular tops with a perimeter of 20 feet and an area of at least 24 square feet. Write and solve an inequality that can be used to determine the possible lengths to which the tables can be made. So in this one, we have to kind of remember some old facts, things about perimeters and areas of rectangles, and kind of those relationships. And so it asks us in the problem to determine the possible lengths. We know that a rectangle has a length and a width, and we know something about the perimeter. The perimeter is 20 feet. So we want to get everything in terms of the length for this one. So remember, perimeter is 2 lengths plus, oops, oh, 2 perimeter, let me erase that. Perimeter is 2 lengths plus 2 widths. And in this case, that's 24. And oh, 20, my bad. I underlined it, but the perimeter is 20, and that's 2 lengths plus 2 widths. I want everything in terms of the length, so I'm going to solve for the width, so I know the width also in terms of the length. I'll subtract 2L, so 20 minus 2L equals 2W. I'll divide by 2. Since everything has a factor of 2, when I divide by 2, I'll get 10 minus the length is equal to the width. 10 minus the length is equal to the width. And so this gives me my relationship between length and width. So I can call the length L and the width 10 minus L. So I have a way of representing each one of those. And so area is length times width. In this case, the area is given as 24 square feet, and the length is just going to be L, and the width is going to be 10 minus L. And actually, I'm going to rewrite this because we know our area has to be at least 24 square feet. So I'm going to say in this case, length times width has to be greater than or equal to 24. And so since it's going to be at least 24 square feet, that's what it is. I'll replace W with 10 minus L. So L times 10 minus L is greater than or equal to 24. And if you remember, these problems that we've been doing have been inequalities. And so we have a polynomial. We want to be able to factor it. And we want to get one side equal to 0 in this case. And so I'm going to get the right side equal to 0. That's kind of the way we've been doing this. I'm going to distribute this. So 10L minus L squared is minus 24. Is greater than or equal to 0. Everybody with me so far and agreeing with that? So I distributed and I got one side equal to 0. Now I want to rearrange this so it's in standard form, but notice my L squared is negative. Since my L squared is negative, I'm going to want to change that to a positive, but when I change that to a positive, I'm going to multiply everything by -1 or divide everything by -1, however you want to think of that. But what that's going to do is it's going to flip the inequality. Does everybody remember that's like the big thing? If you multiply or divide by a negative and it's an inequality, it flips the inequality. So first I'll just rearrange it. Negative L squared plus 10L minus 24 is greater than or equal to 0. And now I'm actually not going to touch that because I like always things to be mathematically correct. So I'm going to take this and that, and what I'm going to do is I'm going to write it so that I'm taking that times -1 and that times -1, and then at the same time I'm going to flip that inequality to be less than or equal to. So mathematically everything kind of follows. This is a correct math statement and this is a correct math statement. Then when I multiply through by -1, this will be L squared minus 10L plus 24 is less than or equal to 0. So it might seem a little unique to you that we're looking for something less than or equal to 0, but it just works out that way based on our problem that we're looking at. So then our next job is to find the zeros. So we set this equal to 0 first, and I'll just write us a note, find the zeros. So I'll change it to L squared minus 10L plus 24 equals 0, factor, and find the 0. So take a moment and do that. Okay, so then when we factor this, L minus 4, L minus 6, so L equals positive 4, L equals 4, L equals 6. In this one, I'm going to do an interval table like I had been, but let's think about this. This is attached to a problem. So since we're talking about lengths and widths, we know that those lengths have to be greater than 0, correct? So when I do my first interval, I might just go from 0 to 4, then from 4 to 6. Then the other one, you know, since the length has to be 10 minus the width, then we can kind of think about what that might be as well. Or if you want to go to infinity, that's fine, because we only want to see what's happening with our intervals. So our first interval, I might just go from 0 to 4, and then from 4 to 6, and then from 6, if I want to go to infinity, that's fine. X, and I'm looking at the sine of y. And right now I'm looking at kind of this inequality when L minus 4 times L minus 6 is less than or equal to 0. That's what I'm looking for as I go through these. Pick a number from 0 to 4 for us. Bo, anything from 0 to 4? 1. And I kind of wrote that a little funny. If I put 1 in there, oh, that's because that's minus 4. Okay, I wrote it a little funny. I'm going to rewrite it. So this is x minus, or L minus 4. That's my problem. L minus 4 and L minus 6. So, Bo, when I put in 1, is that positive or negative? Positive or negative? And a negative times a negative is what? Positive. Pick something between 4 and 6, Madison T. 5. And when I put in 5, positive or negative? Positive and negative. A positive times a negative is a negative. Ellie, 6 to infinity, 7. Positive or negative? Positive or negative? Positive times a positive is a positive. And so we were looking for when this is less than or equal to 0. So the interval that works here is the interval from 4 to 6. So now I'm going to actually go all the way back up to the problem, and I'm just going to make sure I'm answering what the question is. So if you think about this, L has to be in the interval from 4 to 6. And can it be equal to 6 and 4? Sure, it can be. So this is write and solve an inequality that can be used to determine the possible lengths to which the tables can be made. And so we can include those zeros. So our solution is the interval from 4 to 6. They're not undefined or anything like that. And so I'll just kind of show, here's our inequality. And the book author, it's a little hard to see. This is L times 10 minus L is greater than or equal to 24. And then our solution is 4 to 6 feet if we put that in terms of the actual lengths of the rectangle. So that's what we're kind of doing in that type of problem. And it's that same system that we've been working at as we've looked at things. So I'm going to